Hello everyone, this is Pulak from IMESH, and today we'll be discussing how to secure Prometheus scraping with Istio-mTLS. So we'll first begin by discussing uh, what doesn't really work with Prometheus and Istio, and then we'll figure out a way to enable mTLS despite all the limitations that we have. And then of course I'll be showing a demo for this, so let's get started. So if you've enabled Prometheus on an Istio-enabled cluster, this is sort of what it will look like, right? So you've got your applications. Some of them will be Istio-enabled, some of them will not be Istio-enabled. But the main thing is, when the proxy is there, it will expose its own metrics on a particular port, and Prometheus will be residing in some non-Istio-enabled namespace usually, and it will be scraping over HTTP calls only. So everything is going over clear text, and we don't really have much control over this. Now, the very first thing you would think is that to make it mTLS, we should enable Istio injection. Now, that would not work. The reason for that is the way that Prometheus makes these scraping calls. It is sort of incompatible with how Istio is supposed to work. So, because the calls are not the standard HTTP calls that we expect, all the calls will just simply pass through. So, if you put a Istio proxy here on Prometheus, it will still be making plain HTTP calls. There will be no mTLS enablement. So next you might think, okay, what if I apply strict mode mTLS? Surely that should block it, right? But even if you apply strict mode mTLS, and regardless of whether or not you have enabled Istio injection on Prometheus, you will see that the calls will still go through normally over HTTP calls, which is not correct, right? Because normally when you have strict mode mTLS and you have got some application A over here and some application B over here, this application is not Istio enabled and this one is Istio enabled. So all HTTP calls from A to B should fail because of strict mTLS. But this is not the case with Prometheus, right? So it's sort of treated as a special case. And if you go to the TLS settings page on the Prometheus integrations page on the Istio documentation, you will notice that the very first line sort of gives it away. The control plane, gateway, and Envoy sidecar metrics will always get over clear text. So this settings page is not related to what we are going to do today. So we'll focus on the Envoy sidecar metrics and figure out a way to sort of scrape it with HTTPS calls, despite all of these limitations with Istio injection not working properly. So proxy will not work properly with Prometheus. Strict mode mTLS will also not work. So first of all, we need to talk about how sort of the Prometheus scraping is set up in Istio. So what happens is when you inject Istio into a particular pod, it will also inject three annotations. One of them will be to enable Istio script, like Prometheus scraping. The second one will be which path to scrape on. So /stat/Prometheus is the default endpoint. The third one is which port to use. So the default port is 15020. This is sort of an internal port that like Istio-proxy will use. And because this is an internal port, we do not have a lot of control over it unless we make some drastic changes to the way Istio works. So to avoid that one, what we will do, we will open a different port on the proxy. And this port is nothing more than just a front to 15020, right? So all traffic will be redirected there only. But what this will allow us to do, because this is a generated bit of proxy, this is a generated bit of code, sorry. Istio will also add some TLS related settings to this port, but it will not be present on 15020. So that is the main reason why we're using a different port. Next, we'll configure Prometheus to scrape this new port over HTTPS calls. So this will also be done in a different way, because as I said, mTLS will not work normally with Prometheus. We have to configure Prometheus itself to make the HTTPS calls. Thirdly, we'll annotate the service for HTTP scraping. So this is sort of optional. We can choose to ignore it if needed and apply it for everything in the mesh. But for this video, I'll be showing it on a particular application only, and the rest will continue with HTTP calls. So yeah, let's sort of set up the cluster and see that Istio strict mode mTLS does not actually work. So this is what the sort of setup will go into. So we'll have two applications, one HTTP pin and sleep, both are Istio sample applications. I'll enable Istio injection for them, and I'll have Prometheus also running, and you'll see that the calls are being made over HTTP. So let's jump in. So before going to this, let's see what's in the cluster. So there is nothing there. I think Istio system, this is just a holdover namespace. So if I do everything, yes, so nothing is running currently. If I check in the namespace, default namespace as well, you see, there is nothing. So we need to set up everything. Let's get our applications running first. So these are provided with the Istio release. I have put them in this directory. So let me get everything in there. Next, same for the sleep application. Now the Istio injection needs to be enabled, and I also need to install Istio as well. So I'll do Istio.ctl. I'll get the latest version. So 25 is the one I'll be using. And now because I need to show that strict mode mTLS is not going to work, I'll be installing it with a particular flag. This is not required for the like the actual process, but this is just there to show that that it is not working. So I'll do set and will pass values proxy privileged. So this way we can run TCP dump, and so that it is actually making HTTP calls. We'll set it to yes. Next, we need to label the default namespace. And I'll start everything inside it. Now for the new pods that are coming up, get pods. Let me take HTTP as an example. Just drive. So you can see as part of the injection process, we will have, yeah, so these are the three annotations I mentioned, one for which path to scrape, which port to scrape, and whether or not we should scrape it, right? So now we need to set up Prometheus. So first of all, we should add the Helm chart. So we'll do repo add Prometheus community, and we'll get it from this place. I'll have these commands in the description, or there will be a link to a GitHub where you can have a look at the same. Community.github.io. Okay, it's already there, so we should just update it just in case. Update. Okay, everything has been updated. Now let's install it. Prometheus. Okay, and do Prometheus in Prometheus community. So this is the chart we'll be using. Cube Prometheus stack in Prometheus namespace, and I'll create the namespace as well. Okay, so because this is the stack, it will also deploy Grafana and some other things. I should disable that one, but okay, let it go through. I've already configured the values file, but it is set up for something else. Let it deploy. Okay, we'll in that meantime let me set it up, because we'll need to run a port forward to access Prometheus for now. So full screen, I'll do SPC in Prometheus namespace. So the Prometheus we want is this one. This will be a port 1980. Yeah. So we want this service. We'll do kubectl port forward SPC this whole thing in Prometheus namespace, and we want port 1980. Okay, the pod is coming up. Let's see. Okay, it's still stuck in pod initializing. Let's watch it for a bit. I think we should be able to, yeah, it's running now. Port forward. Let's go to localhost 1990. Now, because the pods are completely idle, we should not have any request related metrics, but we will not be checking that anyways. We'll come here to status and target health. And if we look for script pools, okay, so the script pools are not set up, so that is another thing to set up now. So the way this Helm chart would work, and if you're not used to Prometheus, so this approach is not an ideal approach. This is not recommended by the Prometheus team as well. So what they have suggested is they have created these CRTs. So if you look at Okay, I don't need to show that. I have one set up already. So from the, again, from the archive, if you go to soft in the samples folder under 2.5 and go to add-ons, there will be two things. One is Prometheus.yaml. So this is an all-in-one Prometheus setup, and this one will use this this sort of approach with the annotations. But again, as I said, this is not the ideal solution. So we'll go into the extras folder, and there is a Prometheus operator YAML here. So this one has the pod monitor and the service monitor to script Istio-D. So this is for Istio-D mostly. And this one is for the Envoy statistics actually. So what I've done, I have taken this pod monitor and I've created a separate file, which is present here for HTTP only. And I'll apply this one. So this was in, so the only reason we need to modify this is that this has some different releases, and so the namespace and all is different. So it will not be picked up by our installation of Prometheus. Of course, we can configure it either way, but I've configured the pod monitor instead. So we'll apply this. Again, so all this is saying is just look for the scrape annotation and then take the port and IP and put them together and scrape that one. So now that this is up, it will take some time for it to come up here. In the meantime, let's get the TCP dump going. So again, I'll split the view again. Okay, so first of all, we need to get the pod name. So we'll scrape on, we'll sort of use TCP dump on HTTP bin. So we'll do kubectl exec SIT, and this pod will go into the Istio system, Istio-proxy, and we'll run bash init with this socket. Okay, so it's coming up, and you can see it is making HTTP calls to the sleep pod and the HTTP bin pod. So let's get the TCP dump going first. Okay, so inside this, we'll just use the root. So this is why I needed to use that flag while installing Istio. And okay, let's not run the TCP dump right now. I'll apply the strict mode mTLS. So you can see it is in the, I'll put the namespace as Istio system. So it will be applied to every pod in this cluster. I'll do strict mTLS. Okay, and now even though this is there, you can keep on refreshing, and you'll see that it is still able to scrape it. So let's just wait a couple of minutes. A couple of seconds will be fine. Yeah, last script 2 seconds ago, again, it was able to scrape the sleep. So now that we are inside the HTTP bin pod, we'll take a TCP dump. We want to use the F0 interface. So we'll see what is coming into the pod actually. And okay, we need a place to write it. Let's see what is writable. Okay, this path is writable. What else is writable? Okay, it looks like /dev is writable. We can use dev for a while anyways. It does not matter really. So we'll do TCP dump again in F0, and we'll write it to /dev/txt. Okay, let's do test.pcap since we don't need to look at everything. We'll just give it a couple of seconds to grab some scripts. Let's see. Okay, 2 seconds ago. So we have some data at least. So you can see 31 packets is operated. Now let me copy this out. So I'll do kubectl get pods again. I need the pod name. And I'll do kubectl cp, and with pod name, we want /dev/ what was the file again? Here, test.pcap. And I want to store it in this folder only. So I'll do test http mTLS.pcap, and okay, the container Istio-proxy. Okay, so one for this one is there. Now I can open Wirecard. Oh, sorry, Wireshark. and I'll open that one. Okay, so you can see the call is coming, the very first packet it captured is the Prometheus call, and you can see it is coming from this IP 244.2.215. So if we do get pods in Prometheus namespace and we'll do wide, you can see .2.215 is Prometheus itself. So Prometheus itself is making the plain HTTP call and it is going through normally. So if I enable the Istio injection on this one, actually, even if I don't, it doesn't really matter because anyways, as I said, it is strict mode mTLS. So this call from a non-Istio-enabled application to an Istio-enabled application should fail, but it is still allowed to go through. It even responded to 200 OK, and all of these packets are the data. So here you can see this is the actual data. If you go to this endpoint, if you put forward that port and go to this endpoint, you will see the same data here. So now let's go back to the slides. So we have verified that, okay, even with strict mode mTLS, you can see the HTTP calls are still going through and it is not working, right? So now what do we do? So we'll configure Prometheus to first get Istio injection enabled, right? So we have to enable sidecar injection. The reason for this is we'll take the sidecar's certificate and then we'll mount them within Prometheus. As I said before, if we just enable sidecar injection, the way Prometheus is scraping, those HTTP calls will not go through the normal Istio filters and it will just get passed through. Right? So we do not want that. We'll take the certificates from the sidecar instead and we'll make use of them inside Prometheus. And then what we'll do, again, as I said before, we'll open that port 9080 and redirect to 15020, and then we'll add a label or annotation to scrape on that port and we'll verify the mTLS is working. So this will look something like this. So we'll have Istio injection enabled on Prometheus. The slip pod will still be occurring like scraped over HTTP, but our HTTP pods should work over HTTPS. And of course, I'll show how to do this in a generic way as well. It's a very simple thing if you're used to Prometheus. So coming back here, the first of all is the Prometheus setup we need to update. So it is the same helm chart we'll be installing, just we'll be passing some configuration into it. So if you look into what got deployed, as it is the Prometheus stack, you can see they have put Grafana and some other things in there. First of all, I've disabled all of those, whatever is default. I've kept the Prometheus operator and Prometheus enabled, and all of the default scripted targets I've disabled as well. So we will not have all of these extra things coming in here. So you can see a lot of extra targets got added. We just want to focus on this one, right? If you want to enable, again, you can enable everything as usual, or you can delete this. So first, let me uninstall. So I'll uninstall Prometheus and we'll start from scratch again. Uninstall Prometheus. Into Prometheus namespace. And again, we'll install Prometheus. So it is there in this terminal, I think. Okay, it is there here, and we'll simply pass this file here. This is called Prometheus operator mTLS values.yaml. Yes. Now the pod monitor from before is running. So what I have done to configure it. Okay, before going there, let me show how this configuration works. So all of this, as I said, this is just to disable some of the default things that it installs. This is not related to the demo. This is just to speed it up. So Prometheus itself, this is where the key configuration is. The first step is to inject the sidecar into the Prometheus pod. So this label will take care of that. Next, with these two annotations, we're telling the sidecar to export its certificates to a particular volume. And then with this bit of configuration here, we're telling Prometheus to take that volume and mount it within its pod, within its container. Now Prometheus has access to this container, so we need to tell Prometheus to use these particular certificates to do the scraping. So for that, we create a scrape class called Istio-mTLS. We'll not set it as the default, and instead we'll just give the TLS configuration here. And in the pod monitor itself, we'll put the scrape class as Istio-mTLS, so it will use these particular certificates to do HTTPS config like calls. there is this flag called insecure skip verify. This is because of the way the Istio certificates are generated. We need to pass this flag in, right? So now that this is set up again, the pod has gone down. That is fine. Let's see pods in Istio. Sorry, Prometheus name first. Okay, I think the pod mentor is still there, but you can see previously it was 2 out of 3. I'll show that as well. Let's try pod. Prometheus. I mean, yeah, you can see the Istio stuff is already there because one of the containers is Istio-proxy. So Istio injection is working. We have that. We have the certificates inside the like the Prometheus container as well, so we can use them. And this also got defined, right? Now we need to. So this was the HTTP only one that we had modified. I'll delete this one again. HTTP only. And what I have done to modify it, I have created an HTTPS one and one for HTTP. So this is again the same thing, just some slight modifications here and there. For the HTTP one, I'm telling it to drop, like if this annotation, so we'll give a custom annotation called prometheus.io/port override. If that annotation is not there, then you drop it. And then you just use the port annotation instead. So it will take the default port that Istio is given and use that. For the HTTPS one, I'm saying if it is there, then only you allow it and allow like HTTPS calls. And you take the port from the port override annotation and not the default port one. And we are using the script class as Istio-mTLS. So let's apply this. Proxy pod mTLS HTTP. Okay, now let's set the pods. Okay, the pod was up. I just need to port forward again. Okay, now if you go here and cut targets again, okay, it will take some time for it to come up again. But yeah, that's it. In the meantime, let's get the new port open. So with the sidecar CRD, again, just to make it specific to HTTP, I've given the workflow selector here. I'm telling it to open port 9080, and it is an HTTP port. So the funny thing is that this will generate some TLS related configuration inside, and the default endpoint will be 15020. So internally 9080 will redirect to 15020. So let's apply this as well. Okay. Now if you want to configure that it worked, I'll open a new window, and here we can check the Istio configuration. So for HTTP win, we'll do PC all for this particular pod. We should see 9080. Yes, so you can see one inbound cluster was generated, and inside the particular one, you can see some TLS related configuration for port 9080 came in, right? But if we do the same thing for sleep, yes, so there is nothing at all present inside this. So that's how we are separating the two ones for now, but we can apply it in a generic way. Let's see if it has picked them up. So because the annotation is not there, both of them are being scraped over HTTP right now. Let's convert the HTTP bin one. And we'll add in our annotation. Yeah, the template metadata. So we'll do annotations. Okay, it is already there, sorry. I'll put prometheus.io/port override, and we'll put 9080. Okay, give it a few seconds. Okay, it started coming in here. It will go away from the other one as well. And yeah, it is showing up here right now. So next we'll go in and verify this. with the same process again. We'll take a TCP dump and also that it is actually making HTTPS calls, but it should be the case anyways because you can see, so Prometheus itself is, so it went over here. Prometheus itself is making HTTPS calls, and because Prometheus itself is making the calls, Istio-proxy will see that a call like an HTTPS call has been made, and it will simply allow it to pass through, right? So again, the same behavior as before, just in a very different way. And let's see that on the destination side. So again, we need the pod name. And I will inject into it to pass. And do sudo again. Let's see. Let me check what's in dev. Do we still have that one? Yes. No, it is not there. Okay. So, okay, because the pod got restarted. Let me do TCP dump again. I have the command up here. I'll give it a few seconds to let it scrape. HTTP is 10 seconds ago. Okay, let's wait. 15. It should scrape now. 3 seconds. I'll give it one more scrape. 14 seconds. Just 1 second, and yeah, it has scraped again. Stop this, and we can go back and copy that one. Test recap. Okay, the pod ID will be changed. Yes, check them. Okay, the whole thing is just, let me. Okay, so this is the old one with the HTTP call. Let's move into that. HTTPS. And yeah, you can see the TLS calls are being made. And again, let's check with the pod IP. So we'll do pctl get pods Prometheus. This one, we have this IP. We'll check for this one. It was IP.id. Yeah. Yes, so everything you can see is going over TLS only now, and these packets are not readable to us anymore. So yeah, that's it for the demo pretty much. This is how you can sort of configure Prometheus to use the Istio certificates to scrape a particular pod. Now I'll end it here, but before going there, let me just show how to configure this in a generic way. So first of all, we can remove this workload selector. We do not need it. We'll then apply this in the Istio system namespace. Right. So every pod will have this new port 9080, and the default endpoint will be this one. And now, because of the annotation requirement, what we can do, we can come into this one, and here I have put some things to check. So this one is simply checking if a particular port is there or not. So port override, like the annotation is there or not. So in the HTTPS one, I'm checking for both of them, and in the pod monitor one, I'm making sure that the port override is not present. So we can remove. Actually, we do not need the HTTP one at all. So we can remove this wholesale. For this one, we do not need to check this particular port anymore. And here, because we are not looking at the port anymore, we can keep this source level, or we can just remove it altogether. I'll remove it. And in the replacement, because IP is there, we'll say $1 here, and this one, and over here, this will become 9080 or whatever is the default you have chosen. Right. So this is one way to make it generic, but obviously I wanted to make it configurable. That's why we have it this way. So that's it for the video. If you've got any questions, feel free to ask them in the comment section below, or drop us a message, or contact us at imesh.ai. So yeah, thank you, and I'll see you in the next one. Bye bye.